Hey guys, so we're going to try question 9 of 2019 paper 2 mock paper, and this is an area and volume question. Again, there's some noisy bits to this, there's some slightly harder bits to this, and probably a little bit harder than you might imagine that you'll see on your actual leaving cert. We'll give it a go anyway. So, give us a little picture of this reservoir tank there. So it says, the reservoir tank in the water tower is in the shape of an inverted right cone. The cone has a diameter of 24 meters and a height of 12. Write down the radius of the reservoir tank. So it tells you the diameter is 24, so the radius is half of that. So the radius has to be 12. Again, very, very easy marks, and it's all about knowing that the radius is half the diameter. Find the capacity, which is the volume. So capacity is a liquid thing. So find the volume of the reservoir tanks in terms of pi. So that means we just don't multiply out the pi there. So first thing we're going to do is we're going to figure out what formula we're using. So when you look here, it says that it is an inverted cone. So we're going to use the cone formula. So you go to your table book and you find the volume of a cone. So the volume of a cone, and you write down the formula. And the formula is 1/3 is it pi r squared h. Pi r squared h. What do I know? Well, I know r is 12. And I know h is 9, given to you in the question. So I can fill them in. So I can do 1/3 pi r squared, which is 12 squared, h which is 9. And I'm going to put that into my calculator. I get 432 pi meters cubed. So don't forget about your meters cubed there. That's in terms of pi. If you press ST in your calculator, it'll give you a decimal, but you don't need to worry about that for the moment. So what I'm going to do is I'm going to write down my information here before I scroll up, because I might need some of this for the next part. So we got the radius, we got the height, and we got the volume, which is 432 pi. So here's where things get a little bit more difficult. Now, this is probably a little bit trickier than you would get in your leaving cert. We'll have a little go anyway. So, water used from the reservoir tank during the day is replaced at night. The volume of the tank is refilled to 90% its capacity. The diagram, it's not to scale as it says there, shows H, the depth of water, and or the surface radius of water in the tank after it's refilled. So, we get the situation here, tank is empty, at night time it refills, that's 90% of the capacity there. Using similar triangles, or otherwise show that r is equal to 4h over 3. So again, similar triangles is something that you would have done a small amount on junior cert, but it's probably been a while since you've done them. And similar triangles mean that two triangles, right, are the same but in different sizes, so they've got a ratio to them. So you're using a ratio. So one side to the other side has a certain ratio. It's called a factor, and we can either times or divide by it to figure out things. So in this case, we're just going to draw out what we have here. So let's draw it out here. So I'm going to draw out this here, and I know that this is for there, this is H here, and I'm going to call this E, D, and A. Now, you can call it whatever you want there. You can call that point B there, sorry. And call it C. So it's up to you what you want to call it. So I've just done points there. So looking at one side of this, it's a right angle triangle, we know that. It's going to help us. So two triangles, I got AED and I got ACB. A lot of letters there. Don't worry too much about them, but just hopefully we can see that we've got two separate triangles there. The big one, and then this one here. So we know that some of the sides that are similar to each other. So I know that CB. So CB, I'm going to put that means the length. So CB is this side here, right? It's similar to ED, which is this here. Okay. there's a few different variations we can use, but let's use that one. And then I know that AC, so AC here is similar to AE. There. So if you think about it, this side is similar to this side. This side is similar to that side. But I know the information for some of these. Like I know I can fill in some missing information. I know CV is the same as the radius, so I can change that to or. Remember, we're looking for something that has or and 4 and H and 3 in it, so we're looking for things like that. So I know that is or. ED, well, let's think about ED. Do I know anything about that? Well, what we were told at the start, we were told what the radius was at the start. We figured it out. We were told the diameter is 24. We know that that's 12. I know straight away that that's 12. So I can put in 12 there. Second side. Well, I have AC, which is here. So AC is my height of the water. So I'm going to call that H. Don't know what it is, but we call it H. But do we know what AE is? Well, AE was the original height. So from here to here, and the original height is 9. And what I can do is I want to get or by itself. So I can times across by 12. If I times across by 12, that goes. So I'm left with or is equal to 12h over 9. But that can be simplified down, which is the same as if I divide that by 3, which is 4h over 3. Again, look, it's a very difficult question, that. Particularly coming up with even putting in the points yourself. Now these could be any letters here, I just chose them arbitrarily, but the maths in it is, to actually go from here to here is very, very difficult. Probably a little bit harder than you would see on your Leaving Cert. That's why the mock paper questions can be notoriously difficult for those. Hence, find H, the depth of the water in the tank after it's refilled. Give your answer in meters, correct to 1 decimal place. Now this, I think, is a very difficult question. So, I want to figure out what the height here is. Now, a couple of things I know. I know what the volume of this is when it's full. I now know that it's 90% full. So I know what the volume of it is. I can figure out what the volume is when it's 90% full. I just get 90% of the 432 pi. So let's do that first. So let's find out the volume of the tank. And what I might do is I might just scroll up here. So I'm just going to scroll up